All right, note, for the limit comparison test, you do not have to establish the inequality that the comparison test needs. That the comparison test requires. Or maybe you tried to establish the inequality and you found that the inequality you needed actually was not true. So here's an example, and it's problem number 19 in your book. So consider this series as n goes from 1 to infinity of n plus 1 over n cubed plus n. I'm still looking at this problem, and I'm thinking the degree of the top is 1. The degree of the bottom is 3. So these leading terms in the numerator and the denominator, they are the boss. They are going to control what happens. I want to compare this to the series as n goes from 1 to infinity of n over n cubed, which equals the series as n goes from 1 to infinity of 1 over n squared. And again, we know that this series does what? Converges. It is a p-series. P-series, this is going to be one of your best friends here. So this one converges. A sub n is n plus 1 over n cubed plus n. And b sub n is 1 over n squared. And the limit comparison test tells us that we're going to find this limit right here. So I'm going to find the limit as n approaches infinity of a sub n, which is n plus 1 over n cubed plus n, over b sub n, which is 1 over n squared. Well, this is the limit as n approaches infinity of n plus 1 over n cubed plus n. Okay, it's divided by 1 over n squared. I'll write that. Divided by 1 over n squared. And then you know how to divide two fractions, right? You take the second one and flip it and multiply. So n plus 1 over n cubed plus n times n squared over 1. And this will be the limit as n approaches infinity. I'm going to distribute this n squared. It'll be n squared, oh, not n squared, be n cubed plus n squared over n cubed plus n. And this limit equals 1. How do you know? The degrees of the top and the bottom are the same, so it is leading coefficient over leading coefficient, which is 1 over 1. That limit is 1. The limit comparison test says if the limit exists, it's a finite number, and it's greater than 0. Is all of that true? That is greater than 0. Then both series converge or both series diverge. Well, we already said this one that we know about converges. So the one we're looking for, and I'll write by the limit comparison test, By the limit comparison test, this series as n goes from 1 to infinity of n plus 1 over n2 plus n also converges. So your job on the test Thursday night is to give a solid argument and tell us what tool you were using. Tell us if you're using the comparison test, the limit comparison test, if you're using p-series and things like that. All right.